What up, guys, and welcome back, man. That was quick. Hope you got at least a snack before you came back for part 2, but let's get to it, man. We started talking about quadratics and what the graph looks like. Do you remember what the graph of a quadratic is called? Yeah, parabola, man. Let's get one up here and let's talk about it. There we go. You remember that? Good. So the whole point of this video is to talk about some key features, the most important parts of this particular graph right here. So we graphed the most basic one. This is y equals x squared. Yeah, so there's a couple of points on here that we really need to talk about. And the very first one, probably the most important one. Good. Okay, because this parabola only changes direction one time, this vertex is always going to be the lowest or the highest, because remember, we can flip this upside down. It can be the lowest or the highest point on the graph. Yeah, so sometimes it's also called a minimum or a maximum value. Okay, now through that vertex, notice also that this parabola is symmetric. Symmetric. So through this vertex, there goes the axis of symmetry. It's kind of like a line of symmetry. If I folded this parabola on this axis of symmetry, I would fold it into two equal halves. Yeah. Now there's an equation for this axis of symmetry, but remember this axis always goes through the vertex. Yes, we'll talk about that equation in a few minutes. All right, so what else is there? Yes, there's also a y-intercept, right? So in this particular graph right here, the y-intercept also happens to be the vertex, but on a different graph, when we move this around, they're going to be different. But the y-intercept, remember, is where the graph crosses the y-axis. One more special point you need to know about. Okay, last one, the roots, solutions, or zeros. So that's going to depend on your teacher and whoever's teaching you algebra. Roots, solutions, and zeros all mean the same thing as where the graph crosses the x-axis. So in this case, unfortunately, the vertex, the y-intercept, and the roots are all the same. I'm going to move this around in a second and we'll get some different ones. But remember this before I move that, because I'm about to move that. Okay, yeah, not only did I move it, I went ahead and flipped it upside down. Now, it's not going to change what all of these things are, so let's talk about the first one first. Where do you think the vertex is on this parabola right here? Exactly right, 3, 6. Those are the coordinates of the highest point on that graph. So if I asked you if it was a minimum or a maximum, what would you tell me? Of course that's a maximum. Now, if it was a U, then it would be a minimum. Okay. Let's talk about this axis of symmetry. It goes through the vertex and cuts this in half. What would that look like? Yeah, it would look like that. But more important is the equation to that axis of symmetry. You're going to be asked for that. Remember, the equation of every vertical line is going to be x equals. So if the vertex value is 3, wouldn't this x equals value be 3? Exactly right. Quick tip. Axis of symmetry is always going to be the same as the x value from the vertex. Always. If the x value of the vertex is 3, x equals 3 is the axis of symmetry. If that x value was 2, x equals 2 is the axis of symmetry. Yeah, exactly right. Okay, moving on. Y-intercept. Yeah, this graph crosses the y-axis at 3. Coordinates 0, 3. Okay, let's talk about the root, solutions, or zeros. Yes, and there can be 2. Notice this crosses the x-axis twice. Now, the reason they're called zeros is because look at the y value here. The y value, the value of this function is 0. Yeah. Now, at this x value, the y value is 0. That's why they're called zeros. Roots, solutions, zeros, man, I hope all of this helps. Next time we're going to talk about what happens when these graphs get skinny and wide. I'll see you there. Okay, bye.